having me here today. People are saying I'm from the Department of Forest, Rangeland, Watershed Stewardship. I'm actually from the Department of Ecosystem Science and Sustainability. So I think that name has as many syllables as the other name, but it's just to let you know that that's where I'm from. I'm a geographer by training. I've been here at CSU for 16 years and been teaching geographic information systems for longer than that. There's been a big explosion in visualization that's coupled with geospatial technologies that's really driving new and different ways to use and analyze and think about data, and that's what I want to talk to you about today. First of all, there's sort of the landscape that we want to consider that's driving these changes, and one of them is that we're seeing increasingly data-intensive science that's demanding the intersection of big data sets. And just on March 29th, the Obama administration announced that it had a big data research and development initiative that was going to put $200 million towards to do things that look at big data storage, look at big data analytics, and then look at big data storage that supports big data analytics. So these things are really being a force in science right now that we need to be thinking about. The second piece of this is scientific visualization, and just all that SketchUp stuff and the other things you're going to see after my talk there's amazing things going on in terms of visualization. But what does it really mean for scientific visualization? One of the things we need to think about these tools is that it's actually providing a mechanism where we can do exploration through visualization while we do our research. Oftentimes we've used visualization, graphs, maps, tables as an end product. But now we're thinking that this needs to be infused and imbued within the research process in some way, because visualization is a very exciting tool. The third piece of this then is thinking about the power of maps and geospatial technologies, geographic information systems, remote sensing data, the satellite imagery that you see on Google Earth, global positioning systems, those handheld units we take out in the field with us. We can say exactly where we are in terms of latitude and longitude, and being able to see this all in this web-based visualization environment that's being driven by these new technologies. And this is the power of maps that can be for both good purposes and maybe not so good purposes. So good purposes in terms of communication, in terms of planning, things like this. Other purposes that may have to do with sharing data inappropriately, looking at people's sensitive data in some way that there may be issues with that. One thing that we're thinking about is looking at, there's lots of different ways to look at visualization. And so these individuals came up with a periodic table of visualization methods. And you can scroll all over this table, and there's a pop-up for each one of these boxes. So I just happened to pop up on the tree one there, and that shows you a particular type of diagram that you can make. And so there's all these different elements on this particular table in terms of all the different ways that we can visualize data and how we might be able to share that. In terms of thinking about then this intersection of data, this is an example where we can look at the landscape of the city, the SketchUp of the city that's right there with the shoreline, and then the bathymetry of the ocean floor. So we're starting to intersect these data sets and being able to look at them in a holistic framework. We can also take many different data layers and begin to do analysis and examination, exploration of connecting research to different fields, to our resource management methods and ways that we want to be able to find out what might be going on the Earth's surface and intersecting these different layers. So what is the challenge here? The challenge for scientists is to, first of all, link the interdependence and interrelatedness of data that come from multiple instruments, multiple fields, and multiple sources. So the really take-home message of this slide is that scientists have to start talking to different audiences. Scientists have to start talking to computer programmers. They have to start talking to graphic artists. They have to start creating this communication in a way that scientists have not had before, and really figuring out ways that this is integrated into the research experience. So I just want to share a few examples of some geographic visioning, and then I'm going to introduce to you Google Liquid Galaxy and what that is all about. So first example here is looking at what we might call an upside down map. I mean, who's to say if this is really upside down, right? Is it upside down? Do you think it's upside down? It's not really upside down, right? It's just a matter of orientation. So we can look at maps in different ways. We've had that capability to do that. Another thing that we can think about is looking at Tom Van Zant's image. How many of you have seen this before? This is an image that was created in about 1989. It's made up of multiple satellite images collected over a 3-year period. So these images were stitched together. There's actually 35 million pixels in this image. And this is actually really more of a work of art than a scientific product, because there's certain things about this product that would never happen in the real world, right? You would never see the entire world all in daylight. Doesn't have the world at night right now. You would never see it without an atmosphere. There's no clouds here. This has been rendered in a very particular way with colors to make it look pleasing to us. And it's all in the same season. You had never seen green up in both the northern hemisphere and the southern hemisphere at the same time. So we need to be thinking about these visualization tools we have and how we create pictures and what they mean for us and what they mean for our scientific efforts. Another example of ways we can display information has to do with cartograms. Well, cartograms are just maps, essentially, that allow us to look at a particular variable and use that variable in place of area or distance. So in this example, we're looking at population, and you can see that population. We've got large populations in India and China. Another way that we might examine population, this is out of Yale University, where this is a project where they've put really population sort of exploding out of the earth. And this also, you can turn and look at this as well if you visit this website. Another method for maybe considering things is how we can actually put shapes inside of other shapes. So this was a test that was actually done with students around the world to ask them, how do you think your size of your country relates to other countries? And most often students came away saying, well, we think our country's much bigger than it really actually is. So we could actually take all these different countries and fit them inside the continent of Africa. One further example is increasingly we're looking at these space-time paths and how we might understand them. There's a couple of things to think about space-time paths. On the bottom of this, what you have on the floor, essentially, you have your distance, where you're traveling within a particular metropolitan area. And the vertical lines on these are the amount of time you might spend in those particular areas. So, but what's wrong with this diagram? If I hadn't told you that, would you know what it was? So if we do our visualization, we've got to make sure that we're putting the appropriate information on it so people can know what we're looking at and how we might understand it. So some things to be thinking about as we think about visualization. So Google Earth. How many people have been on Google Earth? Isn't it amazing? Wasn't that an amazing talk we just had? I mean, I'm just blown away by all the things that are going on with this. So I'm hoping that I can share something with you that will be equally interesting to you. What we have going on here at CSU is we have something called Google Liquid Galaxy. And this is in the foyer of the library. You can go in there on the first floor, and there's 14 monitors that are stitched together where you can sit in front of this big, huge set of monitors, and you can fly over the Earth's surface and visit anywhere you want and take a look at a particular location that you're interested in. This is an immersive experience. And so what we've done today is we're going to share with you Google Earth, but we're going to project that over here and be able to share with you Google Earth and take you to some research sites and talk to you about some of the changes that are going to happen with respect to how we might be doing science. And I don't know how I shut any of this stuff off. Okay. And then we can fire that up. I feel like we should have that, 2001 music. Boom, 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 boom. So what this is a projection of Google Earth onto this, what we could probably think of kind of like an IMAX projection here. And I just found out that we actually have an IMAX screen here on campus, so I'm very keen to think about how we might think about doing some of this stuff there. I've got some research projects that are going on throughout the world, and so we're going to take a visit there. And we're going to go to the Cache la Poudre first. Y'all know where the Cache la Poudre is, right? It's right here in our backyard. We've got a watershed sitting out here. And the watershed, we've been collecting a ton of data for the Cache la Poudre watershed. And what we've done with this is we've actually it's a lot of existing data. It's a lot of information that's already there from different governmental sites that we can upload on a system. We're able to look at this here, and essentially what we're looking at is the watershed boundary along with the major stream networks that work through there. So we can look at this and be able to look at the different locations there. And you notice that, I think that's really interesting, that on the northern part of this, which is the boundary with Wyoming, it's like the watershed ends. When did a boundary ever stop a natural feature from going where it wanted to go? So be thinking about the limitations of our data in some respects. As we zoom in here, I think we can click on any one of these streams, and we've got information that will pop up with respect to that stream information. So it's all the information that we download from that particular site. We can also load on this a project that was going on with our water tables program that happens here, where we have some historical maps that are georeferenced, and we are able to overlay on the landscape and be able to look at that particular map and draw relationships between then and now. So we georeference a map, we bring it into this, and we're able to actually look at the boundaries of the watershed. We can see this three-dimensionally as we zoom in and start to see how much the different watershed ridges match the actual landscape that we have from our Google Earth image here as well. This was done through Sophia Lynn, who's also someone who works with me quite a lot at the Centroid, and being able to understand how we can look at these particular layers of the information. Another example that we might take a look at is I've got research going on in Mongolia. So we're going to take a flight over to Mongolia and be able to check out maybe some of the study sites that we have there. We have a project going on there where we're trying to understand migration patterns of herders, where they go in a given point in time, and how they move around the landscape and how they're adapting to climate change. And so what we're doing is we want to share this with our different participants in the research project and be able to have a working discussion while we're looking at our study sites and being able to fly into these and actually look at the topography and understand what's going on there and seeing where we might see where winter camps are in relation to other places where people can and cannot go. And one further example that we might take a look at is our trees project back here at CSU. So just thinking about the SketchUp example that we saw previous to this, what's the biggest topic on everyone's minds at CSU right now? The stadium, yeah. So we think we might have a stadium, so let's sketch up one of those stadiums and let's drop it into some of the locations that they're suggesting we have it, and let's have a community meeting like this where we can really talk about what's going on. I think this kind of environment creates an exciting way to talk about issues. I think it diffuses contentiousness and it leads the discussion in a way I think that's very exciting. What this is here was we had an intern at the Geospatial Centroid, and this intern went out and he GPSed every single tree on campus. How many trees were those? They were a lot of trees, like 8,000 plus trees. So he went out and GPSed all of these trees, and now we have a map where we've got these little symbols here of the different types of trees that we've got available. I think I might be running out of time, so I just want to make some points to you before I leave you. One is that I think that this is creating a very new and exciting tool for how we can discuss our research projects, and it changes the research landscape in a way that I think is going to be very exciting. I think it's a great tool that could be used for community discussion about contentious issues, as I just mentioned. And I think that geospatial technology is a key component in the development of this big science, in the ways that we're going to visualize things and how we're going to change some of these visualization techniques. But with that in mind, I want to leave you with two key caveats that I want you to think about. The last I checked, 1.7 billion people had access to the internet. How many people are there in the world? There's 7 billion people. So that's a very much a subset of the total population who have access to this kind of technology. So there's an element of equity and access that I think we need to think about with these kinds of tools. The other one is really the very important aspect of visualization. Not everyone can see. So what do we do about those people who have disabilities or things like that? I think these are key things to keep in mind as we move forward in this very exciting arena, but we do have some important caveats to keep in mind. With that, I thank you for your time.